Welcome back. This is the first video of the three problems that I want to show on the concept of depression of freezing point. So the generic formula is delta TF, which is the depression in freezing point, equals the freezing point constant times molality times I, which is the Van Hoff factor, right? Now, this is a straightforward problem, so there's nothing difficult about it. However, you still have to find this value first before you can solve the actual problem. This is given to you, which is 1.86 degrees Celsius over molality. I is the Van Hoff factor. Sodium chloride is an ionic compound, right? Because this is a metal, this is a non-metal. So this is +1, this is -1. So we only have 2 ions total, so I equals 2. So, however, we still have to find the molality. So molality of sodium chloride equals moles of solute, right, over kilogram of solvent, right? This is pretty straightforward. We do have to find the molar mass of sodium chloride, which happens to be 58 grams over mole. So that means it's 32 grams over 1, 58 grams over 1 mole. So that would be 32 over 58 is 0.552 moles. And we know the mass of the solvent is 40 grams, so it's just we have to convert it into kilograms. So it'll be 0.040 kilograms, right? So molality equals 0.552 over 0.040. And that is 13.79 molal, right? Okay, so now we know this value is 13.79, and we know this is 2. So delta TF is just simply 1.86 times 13.79. I'm going to put all this in brackets, times 2. So times 2 times 1.86. So it's 51.31 degrees Celsius. And that's it. Now, what does this mean is we're putting it in water, right? Water freezes at 0 degrees Celsius, okay? Now, depression of freezing point means that this temperature is negative, it is 0 minus of 51, which is negative 51.31 degrees Celsius. That means when you add your salt to your freezing highway, okay, if this much salt is added, okay, of course you do have to add a lot more throughout the highway, but you have to add, when you add 32 grams of your salt on the highway, your temperature of the road drops from 0 to minus 51 degrees. So if the current temperature on the highway is, say, minus 20 degrees Celsius, that means until the road temperature drops to minus 51, the road would stay clean, okay? So essentially, you've gone past the maximum temperature achieved by the table salt. This is the actual answer, okay? But I'm trying to help you understand conceptually what is really this 51.31 means, okay? So that means the temperature is lowered significantly below 0, which means until I don't think any of the domesticated areas in the world can drop up to minus 51, okay? That's pretty low, okay? So areas where people live, you don't expect it to go below negative 51. Unless you chose to go live in Antarctica, then you chose to live there than the rest of the world, okay? But the rest of the world does not live in areas where the temperature drops below negative 51, okay? That's why people don't live in such cold regions, okay? Anyways, that's the basic application of this equation right here. Again, you do not have to remember this. This will be provided to you in the appendix. However, it is your job to figure out the Van Hoff factor. All right, so the next two problems in some ways uses the same equation, but it's a real testament of how can you go from grams to moles, moles to molarity, molarity to molality. Any of those concepts that you learned in 170, can you reapply those in the context of depression of freezing point? All right, so I'm going to stop here. I'm going to come back with two separate videos, one for each problem, explaining the concept of depression of freezing point from a different vantage point. All right, so stay tuned.